It's a pleasure to welcome on stage Dimitar Simov, Jimmy, and he always has something interesting in store for us. Jimmy has a lot of usability, interaction design, consulting experience, quality engineering, so he's going to talk about, I'm not sure, soft performance laws?
I'll try.
All right.
Thank you. Hello, everyone. Now, the topic is soft performance. I hope some of you have been at least one of the previous soft performance topics or talks in the previous ISTAs. And today we're talking about law. Anybody here because he or she has certain issues with the police and is here to learn about the law? Okay, you're on the right place. Good. Now, let me start first. So if you feel like tweeting, I guess these are the tags you might want to use. First, briefly about me. Obviously, I'm Dimitar Simov. I've been here, and it's a very good experience. This is my fourth time, so these are photos you can see from my previous appearances here on ISTA. I'm working in the field of usability, user experience. And I really believe that IT, the information technology world, can be usable. It's not yet there, but we are slowly getting there in a way or another. And currently I'm working at SAP. And I'm working as an experience officer for one of the products of the company. Okay, now my goal today, well, challenge your common sense. Because things we'll be talking about, they are really common sense. You know all of that. But I hope to be able to give you a slightly different perspective on those things. So before we get really started, let's have a brief recall of what I'm talking about. So when we talk performance, these are dictionary definitions of what performance is. And we are not interested in the second definition. The capabilities of a machine, that's real performance, that's the hard performance, the number of bytes, the number of bits, number of cycles that the machine is capable of performing. We are interested in the first definition, task, how successfully a task can be implemented or completed or finished by the person who's doing the task. That's the soft performance part. That's how we humans perform. And let me walk you briefly through what this whole thing is about. Back in 2013, I introduced the topic of soft performance, and then I claimed that there are certain things that affect how we humans deal or how successful we can be depend on these things, like how the texts are formatted, how they appear on the screen, crucial for performance. Then we talked Fitz's law. Anybody here remember the Fitz's law? Anybody know what I'm talking about? There's one person there, a couple. Okay, for the rest of you, Fitz's law states the obvious. It says that the time it takes for a person, imagine somebody holding a mouse and trying to hit the target on the screen. So the time it takes this person to hit the target with the mouse depends on the size of the target and the distance to it. Which means if the target is big and close, you can very easily click it. If the target is very tiny and far away, you have to very precisely go to it. So it takes a lot of time. Now, layout and structure. These are very important things for how we perform, how we order, what defaults we use. Like Afghanistan, anybody remember why Afghanistan is there? We have somebody. Yeah? This is the most, used to be, not anymore, the most populous country in the world in terms of internet population. Why? Because Afghanistan is in the top of the list. When you sign up for a service, you just pick Afghanistan, right? Okay, user success and engagement. We humans don't want to waste time, don't want to feel like we're wasting time. Therefore, keep us engaged and we feel happy. Presentation of progress is something that also affects how we experience performance. We feel more, we feel like we are working faster if the progress indicator speeds up as it goes along. Strange, but fact. And then aesthetics. We also discussed that when something is beautiful, we feel like it works better and we are working better with it. Okay, that was 2013. Then 2014, we talked about messages. Again, how we as designers, developers talk to our users is critical. If they don't understand what we are saying, they can't perform their tasks. So the thing about messages was that we should try to avoid messages as much as possible. Instead of writing messages, we should be trying to design and build interactions. Okay? Then if we have to give a message should meet these 4 points, and it's like, okay, who's showing that message? What has happened or not happened or will not happen or might happen, so that the user should know something, why this is the case, and then what this person can do to avoid the situation or get out of it. And then the third most important thing is forget everything that I have said and do whatever makes sense at this particular situation. Now, last year, they warned me that this might be a short cable. But okay. Last year we talked about metrics, how we measure soft performance. And now there was this trinity: effectiveness, how successful users are, whether they can achieve their tasks. Then efficiency, how long does it take them to achieve this task, or what effort do they spend trying to achieve the task? How many errors they make in the course. And then satisfaction. And we discussed that there are 2 levels of satisfaction. Task level, I performed this specific task, easy or hard, or overall satisfaction with the whole product. And now back to, or not back, but forward to this year's ISTA, laws and principles. Okay, I start right away. If something is not clear, let me know. Occam's Razor. This is not about shaving. I'm sure many of you know Occam's Razor. So it says that among competing hypotheses, the one with the fewest assumptions should be selected. This wisdom was achieved back in the 14th century by somebody, William of Occam, who is an English Franciscan friar, also a philosopher, theologian. You couldn't be a philosopher without being a theologian at the time. And it is also known as the law of parsimony, lex parsimony. Why? Because we people are lazy. We want to be to save, to not waste the energy on things. And here's an example of Occam's Razor in the internet world. Now this is the success rate of users in the Scandinavian, which country? Sweden, Norwegian, Sweden maybe, who was supposed to find a service for their passport. Either change it, issue a new one, or whatever. Back on, so it's your left, you see in 2014 the success rate for this service was 94%. That means 94% of the people were able to find the service that they needed without help by anybody else. Then they made a redesign in 2015, and the success rate dropped to 53. This is, well, a drama, isn't it? And then they redesigned again after evaluating the issues, and they raised the success rate back to 100%. Why was this? Well, you see in the middle, they introduced a map That's a new technology, right? It's very cool to have a map so people can just go find their city, town, village, or whatever it is, click on it, and be presented with information about their passport service. Well, it didn't work because too many assumptions that they should be able to know what a map is, know how to use a map, be able to navigate the map, and so on and so on. And what was the simple solution? Well, they just came up with a text box where people write their zip code. And voila, they have the service. So the simplest thing, this text box works better than the complex, sophisticated map. Now, how do you use the Occams Razor to boost soft performance? And I'm sure by now you all know that soft performance is not soft skills, but user performance. Try to go to solutions that require less effort from users. Mental effort, physical effort, and try to offer fewer interactions. If it can be achieved like one click, good. Okay, next law. Actually, this is the first law. It's called Conways Law. Now, it says that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. What does this mean? An organization will recreate itself in every project that it has. So this was coined back in 1967-68, so by now it's 50 years old, by Melvin Edward Conway, who's a computer scientist and a hacker. All this talks about this organizational self-centeredness. Every organization in the world, as far as I know, is self-centered. This is important because whenever this organization has to do something, what does it do? Recreate itself. Now here's an example. How does this company organize its clients? Yeah, it has a building, this very nice building, and there are two doors. Corporate this way, personal, individual this way. Do we think this way as users? I doubt it. So how do you use Conway's Law to boost performance? Well, study how users think about the domain or the subject. We people form these things that are called mental maps. That is our representation of the way things work. Well, build the thing based on these mental maps, not based on your own structure. But building based on your own structure is easy because we just saw the Occams Razor, right? For us as an organization, this is the normal thing, the least number of assumptions, so that just goes there. Something else that can help, bring external people. They are not in your organization, they are not biased, so they might be able to bring some new stuff. Okay, next. That's called Jacob's Law. We saw how an organization can build something based on its own understanding. But this Jacob's Law comes and says, well, users spend most of their time on other sites. We might be very self-centered. We might think that the universe rotates around our organization, our own site or product. The fact is that if you sum all the time that the user would spend on your site and all other sites or products out there, the other products and sites win because there are too many, so many. And this is very nice, very interesting, because it means that users get familiar with things from elsewhere. And when they come to your place, to your site, to your product, they would expect it to work the way the other websites and products work. This was observed not for the first time, but recorded for the first time by Jacob Nielsen. Jacob Nielsen, anybody? You never heard of Jacob Nielsen? Oh, Read about Jacob Nielsen, please. So he postulated this law. And what's the big thing about it? Think about this website. Anybody, have you seen this website? Where you interact with the website. It's very old, it's at least 10 years old. You don't click. You have a mouse, you navigate the site, but you don't click. This is a homework. Go find the site is called Don't Click. Go find the site and try to use it without clicking. Let's see how much you can go through it. And maybe 30 seconds, something like that. I haven't seen somebody who doesn't click. It's just so inbuilt in us, ingrained. We have a habit of it. We have to click. And this law does not apply to internet things only. It actually applies to all other things in the world. So this is on a street light post, and you can request green light. You can do something with this thing, yellow big thing, and change the light so you can cross the street. How do you do that? Anybody? Like guesses? Press? What? It says drucken there. Of course, if you speak German, you know probably what to do, but you have to press the whole big thing in the front. And I tried pressing the red button there, tried pressing the button on top, I tried pulling the thing. It's just... And this thing is really low because they made it for people in wheelchairs to be able to see comfortably. So like it's this height, maybe like this. So I see it from the top. So it's not very intuitive for me to press this button. Or think computer software. Save as. Most programs, if you click Save As, you see this dialog that shows you your structure and gives you a place to type. I'm talking Windows here. Mac is a little bit different. But Office, well, when you click Save As, you don't see this. You see this other thing that's been around for like, how many? Like 5 years already. And you never know what to do here because it's different. Okay, so how to use this law? Well, stick to what others are doing. Stick to conventions. Of course, this doesn't mean that you should not be trying to invent new things, but when you do, make sure that your users understand those. Okay, next. Moore's law. Now, Jacob has another thing. He didn't coin just one law. He coined another law about the bandwidth and how bandwidth dictates user experience. And that second law of his is based on Moore's law. Anybody knows the Moore's law? Now we're talking. Good. Just in case somebody doesn't know. So the law says the number of transistors on a square, like inch, centimeter, millimeter, or whatever, on an integrated circuit doubles approximately every 2 years. And this law has been postulated in 1965, and for the last 50 years, it has been proven true. Never in the world there has been a geometric progression that has worked for such a long time. This is incredible. What's happening today with the law? Well, maybe it's slowing down, maybe we are hitting the limits of the nano or pico, whatever the meters there that will limit us at some point. But it's amazing. But what's happening is that it's giving us bigger hard drives, faster, more powerful computers, cheaper IT equipment. Why I'm talking about this? Well, think about Google. this is the fastest search engine, right? And they have really hit it. They have hit the hardware performance limit. I don't have the video here, but there's Google's designer who said, I went to the engineers and told them we have to make Google search faster. And they laughed at me and told me, okay, we have to overcome the speed of light limit. And he said, no, that's not the way. And so what did they do? So hardware speaking, we're there. Like, this is instantly fast. But I don't think you remember, but Google's search box was this small. Now Google search box is this big. Google is investing in speak to search, voice recognition technology. If you can read that word at the bottom, if you are able to speak that word into your phone, Google will find it for you and tell you what it means. But I don't know which is easier, speak or type this particular word. Anyway, so Moore's law. Now that's a shame, isn't it? Copy paste. Okay. So how do you use Moore's law? Well, don't rely on the technology. Don't use the greatest. No, it's not there. No, it's there. I know now. Okay. Don't rely on the greatest thing out there. Try to stick to what your users need. Of course, use the technology wisely. But now, if you remember that Moore's law says that hardware gets faster and more. Worth's law. That's a difficult word to say, worth. Like worth, but not like this. So it says that software is getting slower faster than hardware is getting faster. That's amazing, isn't it? So we can do all those strange things with software and actually overcome this speed, this boost that we have achieved through hardware. So the Worth's law is postulated in 1995. Nicholas Worth, computer scientist, actually the author of Pascal. Maybe some of you here would know that. So this is about software bloat. That's another word that you might hear about when thinking about Worth's law. And I said what it means. But here's a specific example that they give about Office. They have this testing lab or studio that are doing different performance tests, and they compared back in 2007, compared Office 2007 to Office 2000, like for 7 years. So Office 2007 was performing worse than Office 2000 on a typical computer of the respective year. Which means, well, the hardware was like 10 times faster, but the software was performing slower. What does it mean? We can't build software well enough, or we just don't pay attention? So that's the combined for Moore's and Worth's law. Sorry for the previous slide. When thinking about that, don't rely that the faster computer will do the thing for you. Well, as you see, it's not really the fact. Always try to measure how your users perform. Yeah? Metrics, effectiveness, efficiency, success rate, these are the things that matter, that are important. Now, I have a task for you, or a small challenge. Pick the one that you like most. Did you manage to pick one? Yes? Okay. Now, again, pick the one that you liked most. In which case were you faster in picking the one that you liked most? Orange? Green? Who's for orange? Who's for green? Come on, folks, you're not here. No, that's not. Well, there were more hands up for the orange. And that's normal. That's the right thing because of Hicks Law. And Hicks Law says that the time it takes to make a decision depends logarithmically on the number of possible choices, which means the more choices we have, the harder and slower it is to make a decision. Now, this was postulated back in 1950s by William Hick, who was a British psychologist, but you might encounter this law as the Hick-Hyman law, because Ray Hyman worked on the same topic, and actually the two guys worked together, so they helped each other in a way. So it's either Hicks law or Hick-Hyman law. Okay, so here's an example of Hicks law. You want to buy something. So the number of choices that the service, software, product, a company offers might be crucial for this, whether you pick something or not. And here, like Assure, yeah, they have like 1, 2, 3, 4, 5 choices. Yeah. Sorry. Here's another example of Hicks Law. This is the Cancer Registry of Norway. This is their website before a major redesign. And what the Cancer Registry wanted, they wanted to collect money from people. So that's why you see on their website, support us, donate, register. So they have like 4 different calls to actions that are geared towards collecting money from people. How well did they do? Not really well. So they analyzed the user's needs and tasks and redesigned the website. And today the website looks like this. Now there are only 4 things here. And this is the chart of the donations that they collect. By gearing the site towards what users need, because users came here to learn about cancer, not to donate. But by being able to accomplish their tasks, users are satisfied, so they're more likely to donate, and actually their fiscal statement shows it. So choices. Here's an interesting book and a paradox of choice. You might want to read this book. It discusses in much detail things about how we choose, why we choose. There's this interesting example at somebody trying to sell jam. So jam, I mean, in jars, like this sweet thing. And they went to this big shop and they offered like 20-something or 40-something different jars. And people would just pass by and nobody will buy jams. And on the next day, they just left 6 jars. People started buying because they reduced the number of options, so it was easier to choose. Okay? So how to use this law? First thing, know the goals of your users, their needs. How do you know this? Perform task analysis. What the task of your users are. Now, when presenting number of options, be careful. I won't tell you don't offer more than 4 or more than 6, because it doesn't make sense. But in every particular scenario, it will be a different solution. When designing the thing, try to reduce the number of options, the visible number of options, or hide certain things that are not very important or critical. Another thing that might work well is to offer step-by-step guidance so that it's easier on users to go through your product and choose. Okay? Hicks Law. So far we were choosing. Now let's see something different that's related to the way we choose. And this is related to our memory. Miller's Law, it's called, and it says that the number of objects that a average person can hold in his memory is about 7. The magical number 7 plus minus 2. Anybody heard of this? Yeah. So again, this is old stuff. 1956. George Miller, very famous cognitive psychologist, psycholinguistic. But the whole thing is that the human memory has limited capacity. And that's about a couple of bits. Of course, it varies based on the type of sense that we have to use, whether it's sound or smell or whatever, but that's the gist of it. So I want to read this. If I told you to remember it, it's hard. If you see in the second row, it's the same thing, and you can read it faster, can't you? Or this, compared to this. If I told you to remember this, it might be hard for you. At least you will take more time because it's not chunked. And by breaking it into pieces, we are making it easier for the memory, for our cognition to process the information. So that's the whole story about Miller's law and the magical number 7. It's not 7, so let's forget about that, but Miller's law. It's about chunking information in such a way so that we humans can process it more comfortably and faster. So how to how to use this law? Don't make your users remember things that you can easily show them. You remember, like a checkout process or registration process. What did you choose on step 1? What did I choose? What did I write there? Did I write I was from Razgrad, or did I don't remember, because it was like 5 seconds ago, 15 seconds ago. So if you can show them on the screen that information, do that. Break information into chunks and use some meaningful delimiters so that it's easier to comprehend. And of course, no, it's not necessary to limit the number of items to 7. A menu can have 15 items. That's okay. Nobody disagrees? Whoa. Good. Now, that's an even harder thing to say. Well, not, because this is Zipf. The P is silent, it's just Zipf. And Ziff's law says that that's the longest one. Now, it's very difficult in the beginning to understand, but it says, well, like in a book, imagine a book that was written by a single person. So the frequency of the words in that corpus, that's the corpus body, is inversely proportional to the rank of that word. That means the word that's ranked number 1, you will see the biggest number of times in the text. The next most common word will have number of occurrences that's twice lower. So if the first word you see 1,000,000 times, the next most common word would be 500,000 times, and the next one will be 330,000, and so on and so on. That's a very interesting law. I'm not sure that we have figured out why this is the case. Maybe because of cognitive ergonomy, but people are still trying to figure it out. Still, postulated 1935, again, old stuff, 8 years old now. The interesting thing is that this Zipfian distribution does not apply only to the words in a linguistic body, but to all kinds of things like salaries, the population of cities in a country, but more interestingly to website popularity, to the pages on a website, and to user tasks. And now it's getting interesting and related to soft performance, isn't it? You can see this also under the names of long neck or long tail. Maybe these are more popular than Ziff's law. So this is how it looks. The image on the left and the image on the right are the same thing. the image on the right has this, is shown a logarithmic scale. So when you see this this chart, you would know that. But you see that I don't have a pointer here. So here on the left chart, or on both charts, on the left, these are the tasks or the items that have the biggest frequency. That's why the chart goes high above, very, very high. And as you go down to the left, the number of instances. This one that you see here is the real distribution of the visits to the documentation of the product for which I'm working, HANA Cloud Platform. So the pages at the left, they have like 70,000 visits, and the pages on the right, they would have like 1 visit. So this is for about 1,000 pages on a website. Okay, so what does it mean? Well, there's only one thing here. Know your users' tasks, because your users come to your website for the top 2 or 3 things that are on the left. These are the most important things. So either a website, a product, anything could be. You should be aware, you should know these, and you should prepare your product to serve these top 3, 4, 5, whatever the number of tasks, impeccably. Okay. Now, this is not really a law, but I'm sure you have heard it. It's called Don't Make Me Think. It's a book written by Steve Krug, and it says that a software program or website should let users accomplish their tasks easily and directly. So what, you would say? Well, the thing is that this means that the tool must be invisible. This means that you should design your software in such a way that users should not be thinking about the tool, how to use the tool, but how to accomplish their task. I hope you can make the difference here. Yes? Think about the task, not about the tool. Okay, let's go further now. You tired? I have 33 more of these. No, that's the last one. Norman's Law. And it says that a project is behind schedule and over budget on day 1. Nice. So what? How is this related to soft performance? You would say, well, you see. Now, Donald Norman is the person who postulated this law. He's one of the contemporary gurus in the field of design. But he says, okay, since the project is anyway late, we don't have to waste time and money on doing research up front. We should start designing and trying things. Instead of doing research, let's first try to do things. And why can we do that? Well, because we have pre-existing knowledge about the domain, he says. Because nobody is like coming from the moon and without any knowledge about the web or the software or the way things should behave or interact. We have a lot of knowledge already. So we can really start experimenting with that knowledge and throwing in crazy ideas which we can then try. So what he says is, well, another thing that he says is, if we do too much research, that might inhibit our creativity because we'll get bogged down very deep in that research. So instead of researching and thinking too much, well, he says, well, sketch and try things first, then analyze. So first try, then think. And then iterate. That's it. Iterate. And there we are. Iterative design, agile approaches to software, so on. And of course, bring in domain expert if you're not familiar with the domain in which your product is working. Okay, so that was the last one I said. Let's recall what we discussed today. These are the laws and the principles. Actually, there are 10 of them. Well, I did not intend them to be 10, but I got it there. So Occam's Razor, this was that go for the simplest thing, right? Then Conway's Law, organizational self-centeredness. We should try to get out of there. Jacob's Law says people spend more time with other designs than with ours. Then Moore's Law says that hardware capacity doubles every year or so. And Worth's Law says, well, but software bloats faster than hardware speeds up. Right? Hicks Law said that, well, if there are many choices, decisions get harder. Miller's Law said, well, our memory is limited in capacity and processing. Then comes Zipf, who says, well, frequency is inversely proportional to rank. So what? There are some tasks that are very important and we should cater about them. So don't make me think, make products that are invisible, right? And Norman says, well, a project is always late, so let's sketch, try first, and then think and analyze. Well, that was all. And if you have questions, I would be glad to answer.